Hello, you wonderful earth science kids. Mr. Johansson here again. Today, right now, I want to talk about scientific notation. Well, scientific notation is a way of expressing numbers that are either too big or too small to easily express and making sense out of them in a useful way for science. By the way, there's a whole other reason to use scientific notation that we would get to if you were studying a more advanced science like physics or chemistry, which will show you the accuracy with which we know a number. So sometimes it's used for just ordinary sized numbers as well. It's the proper way to express numbers scientifically. But here is scientific notation. Consider 243,000 meters. How could I express that in scientific notation? Well, ask yourself, where's the decimal point here? All right, it's right here. So I want to move the decimal point until it's behind the very first digit. And I want to count how many jumps that took. Be careful when you make this count. I would use a pencil and just actually make the count and count each jump. If you're off even by one, it's an order of 10, so you're really quite far off. So 1, 2, 3, 4, 5, 6. So we could write that then, 2.43 times 10 raised to the 6th power, and we put units down. Pretty straightforward. Try another one. Okay, what number is that? Thousands, millions. That's 17 billion grams, people. It's a lot of grams. Okay. What would the number be expressed to scientific notation? Well, 3, 6, 9, 10. 1.7 times 10 to the 10th grams. This is easy, okay? But we also use it to express very, very tiny numbers. In science, we have to deal with whatever numbers nature gives us. Some of those numbers are really tiny. Well, what do we do for a really tiny number? How about 0.000000037 grams? This would be a light object. What do you do here? Well, we see the decimal point right here, and we're going to count how many jumps until it follows the first non-zero number. And we're going to then, because we're moving to the right, that's negative exponent. So let's try it. Here, just make the jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'd say 3.7 times 10 to the minus 9th grams. That minus means the decimal point moved to the right. Okay? Not so hard. Now let's try reconstituting a number from a scientific notation. So if I had 3.6 times 10 to the 4th meters, 3.6 and move the decimal point. That's positive, so we're moving the decimal point to make it a large number. 1, 2, 3, 4. Put the zeros in. Comma, 36,000 meters. Easy as that. Okay? How about if we had 7.9 times 10 to the minus 8th, and try meters again. This is something really small. All right? So check that out. 7.9. Now, because it's negative, we're moving it that way, making it a very small number. 1, 2, 3, 4, 5, 6, 7, 8. So you put a 0 and a decimal point there, and a 0, 0, 0, 0, 0, 0, 0, 7, 9. So I moved the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, just like it says. So this would be 0.000000079 meters. And you can see the use of scientific notation. It would be very easy to misstate the number of zeros here. And that would make you enormously wrong by a factor of 10 if you just forgot 1 0. So scientific notation is a handy way to write numbers in this new manner. Hope that helped.